Started in September 2019, AIDEO is a research project funded by ESA that aims to automatically integrate Earth observation data and artificial intelligence to monitor and forecast West Nile disease outbreaks. What is West Nile disease, and how did the idea for this project come about?
West Nile disease is a zoonosis caused by a vector-borne virus circulating in birds through mosquitoes. Climatic and environmental factors influence its transmission cycle and are key factors for understanding the seasonal and geographic spread of the virus. The project investigated the relation between virus circulation in animals and Earth observation data using artificial intelligence techniques. The final aim is to develop an alert system to know when and where the virus might spread, depending on favorable conditions, so to put in place a better targeted surveillance. We believe that Earth observation and artificial intelligence can hugely contribute to discover new relations and to predict patterns in health issues. In the next decades, the greatest challenge will be moving from big data towards creating value.
Different fields of expertise are crucial for effective West Nile virus surveillance, and the AIDEO project has seen the collaboration of 4 complementary Italian organizations in its consortium. This collaboration resulted in 2 different models, one using features extraction from the EO dataset, applying a gradient boosting algorithm, and a second model that analyzes the 20-meter Copernicus Sentinel-2 images using a deep convolutional neural network. How could these models combine animal disease data and EO data?
First, we identified the virus circulation area with all veterinary cases officially reported since ever. Among them, data from the last 3 epidemics were used as ground truth points for model training and validation. Then, the baseline model associated the ground truth points with 70 Earth observation variables, lagged over the 6 months before the infection. MODIS daytime and nighttime temperature, MODIS NDVI, Copernicus soil moisture were used to predict the spread of the virus with a spatial resolution of 2050 meters and 16 days in advance. The classification task was solved with an extreme gradient boosting algorithm, with an overall accuracy of 0.84.
Earth observation data needs to be carefully arranged to be used for specific analysis. So how was EO data processed in order to contribute to the AIDEO project? And why does analysis-ready data matter?
Earth observation data need to be specifically prepared in accordance to the requirement of the exploitation process. For the AIDEO project, we produced and delivered analysis-ready datasets tailored to artificial intelligence requirements. This considerably facilitated geodata exploitation and value-added information retrieval. In particular, we have harmonized heterogeneous datasets composed by Sentinel-2, Landsat-8, Sentinel-1 surface soil moisture, Sentinel-3 land surface temperature, and SRTM digital elevation model, in 10 series data stacks over the West Nile disease infection points. To complete this task on time, we have used our high-performance computing environment optimized for the execution and parallelization of data-intensive applications, the Earth Console P Pro. Furthermore, the project inspired new ideas, for example, how to improve the completeness of time series in case of missing observation due to clouds or invalid pixels. To this end, we implemented a new tool, and the results are really promising. We plan to make it available for future use cases like AIDEO.
The second model integrates West Nile disease outbreaks and EO data using the deep convolutional neural network. What about the Almage Lab Contribution, and how can the AIDEO findings be applied to other EO applications?
The core of the project from Unimora's side is the design of a novel deep learning model capable of extract as much knowledge as possible from unsupervised data by solving a pretext task such as colorization. In this case, we were able to design a model that is able to work with a lot of Earth observation data with just few supervision, as in the case of the West Nile disease. Coupled with this model, we have a graph-based inference method that is able to reach 80% F1 accuracy in the task of West Nile disease detection, and can be applied also to other Earth observation tasks such as land use and land cover classification, semantic segmentation, and detection as well. We believe the result can be applied to a lot of different Earth observation problems, so we have developed some basic research that can be used also onto a multitude of different problems in the future.
According to the principles of the One Health approach, promoted by WHO and OIE to protect human and animal health, multiple sectors are called to work together to achieve more effective results.
Main keys for success are cooperation, dialogue, open data, multidisciplinarity, and innovative minds.
Certainly, IDEO is taking a significant step forward in this direction.